Welcome back. We're the fourth section module already to get started and tuning your SQL Server for SharePoint Jumpstart. Bill, how you doing?
Great. We had to took a longer pause than we needed to. Again, yeah. Frank or Brian with the hair.
Yeah.
So
it looks better though. I think more powder is going to help with the glare.
A couple of things I wanted to address before we even got started with the next module. If we can flip over to my machine again, we'll have a look at a couple of things. First thing Brian talked about in the last module was SQL Server memory. There's a couple of different ways that you can figure out what you're working with. Again, using the dynamic management views is a great way. So take a DMV, execute, and as you can see, I have approximately 8 gigabytes of physical memory available to me in this instance. The other thing I wanted to show, because a number of questions are coming up around how did I measure the write cost as related to shredded storage. So basically what I did from a write cost measurement perspective is, again, we go all the way back to DMVs, and that's what I use there. So if we come over, I'm going to execute this query against my content database. I'm using the following DMV. You can see it here, IO virtual file stats. It's not AdventureWorks, so what we do is we just come in, because I'm not going to use my AdventureWorks DB, that's for BCS, and execute. And as you can see, I get a number of reads, I get a number of bytes read, I get a number of different metrics. So when I did the demonstration on shredded storage, effectively what I did was I put together a little C# app that reads the current size of the log file. So what's its current physical state in terms of size, number of writes, etc. I then, within that same piece of code, ran the query and then took the result of the query and subtracted from it the actual the initial size. So the end result minus the initial size roughly gives me an idea of what the approximate write size was. So that's generally how I came up with that number and how that worked in general. So I just kind of wanted to share a few of those things. Again, we're going to try to answer as many questions as we can. I've got to be grateful to Frank for pretty much covering the last module. I had a very compelling game of solitaire going.
Absolutely,
so,
yeah. And he won one too, I think.
I did.
Definitely, so that's good. All right, folks, all right, here we go again. So what we're going to do here is we're going to dip into the fourth module. We're going to talk about avoiding large log files. I don't know how many times I've presented, and I just do a quick show of hands. How many people have seen these ginormous transaction log files? And I've been on sites and doing consulting, and one place had a 384 megabyte, just megabyte MDF file, and they had 11.2 gigabyte LDF file. So we're going to talk about how we can address that. And there's, if you search online, you're going to say put it in simple recovery model. We're going to tell you, yeah, let's not do that. You've already seen the repercussions with that. And we're going to go through an example of that. We're going to look at locations of backups themselves. We're going to talk about the SQL Server 2012 always on, and then we're going to wrap up with a few slides on just some best practices that we've discussed throughout the course today. So the agenda for here is avoiding ginormous Tlogs, talking about backups, always on, verifying the integrity of your database, back to what Bill said, the good old DBCC command, and then SQL Server for SharePoint best practices. So how do we avoid those annoying ginormous transaction log files? Well, as we talked about earlier, we've got the simple recovery model, and you may search on the internet and might search and might come up and say, well, what you could do is put your database, your production database, in simple recovery. But if you do so, this is what happens. Every time that checkpoint writes, which is approximately every 60 seconds, it's going to delete the content of the LDF file. Will this prevent my transaction log file from getting too large? Absolutely. It will resolve that problem. But what I want you to do is use the full recovery model. And the full recovery model, as you've seen already, is the same type of write on the checkpoint, but what it doesn't do, it doesn't remove the content out of the LDF file. Why is that important to me? Well, when we just went through the previous module, and we talked about how we want a separate drive for your MDF file and a separate drive for your LDF file. The reason is because if I lose one drive that contains my MDF file, I still have my transactions in the LDF file. So I'm going to walk through a scenario with you. One that'll give you the opportunity to prevent the ginormous Tlogs, and the second part of this that'll be good is I can still do a recovery because I'm not going to use that simple recovery model. So let's set up an example here. Let's say, for instance, every Sunday night I do a full database backup. Here's my LDFs writing to my MDFs using the checkpoint process. So Sunday nights I do a full database backup. Monday through Friday I do a differential. Remember to remind you, a differential means it's kind of like a cumulative update, or backup, excuse me. Sunday is a full backup. Absolutely everything gets backed up. Monday I do a differential, all the changes from Monday will be backed up. Tuesday I do a differential, all the changes from Monday and Tuesday get backed up. Wednesday I do a differential, all the changes from Monday and Tuesday and Wednesday. Why would I do that? Well, if I want to do a restore, what do I want to do? I want to minimize my downtime. So instead of doing a transaction log backup on Monday, Tuesday, and Wednesday, and having to restore on an issue that occurred on Thursday, I would actually just have to do a full restore from Sunday's backup, jump right over to Wednesday's. It's got all my transactions that took place between Monday, Tuesday, and Wednesday since the full backup. So differentials have the opportunity to minimize the downtime, because at that point what we're doing is, instead of doing 4 recoveries or 4 restore operations, the full transaction per day, I do a full. I jump to Wednesdays, which is the last differential I did, and I do a recovery of that. So that shortens that downtime for that content. All right, let's go to a situation here. Let's say on Thursday I lose one of my MDF files at 4 p.m. So Thursday 4 p.m. one of my MDF files that I've been backing up in the scenario in the top line here, it gets toasted. That drive crashes. My LDF file is on a separate physical drive. What I'm going to do to try to recover this, and the only way I can do this is because I'm using full recovery model. The first thing I'm going to do is, because I have content in the LDF, the first thing I'm going to do, as you can see, the number 1 shows up to the right of this command, is I'm going to back up the transactions that are in the LDF file. All right, MDF file went down, but because I'm not in simple recovery model, I still have all the transactions for Thursday in my LDF file. So thank goodness I'm not using simple recovery model. So the first thing I'm going to do is I'm going to get a backup of the LDF file. Now I've repaired the disk and I'm going to restore the content. Now I'm going to go into the restore process. The next thing I'm going to do is I'm going to restore the full backup from Sunday. You'll see that green 2 appeared up there. So the second step I'm going to take now in the restore operation is to restore that full backup. Now, because I'm doing differential backups, performing differential backups versus transaction log backups, I don't need to worry about Monday and Tuesday. My third step is going to be to perform the restore of the Wednesday differential backup. So now I've got my content backed up, or restored I should say, up until Thursday or Wednesday night. If I was in simple recovery model, I'm done. I can't do anything else because I don't have anything in my LDF file. But because I'm not in simple recovery model, I'm going to go another restore operation down on the bottom line, and number 4 shows up over there. That's going to show you there where I'm going to restore the transaction log that contains the transactions from Thursday. So now in a sense, minus maybe a transaction at the very last minute, I haven't lost any content. If I'm in simple recovery model, I can't do step number 4. I can't even do step number 1. So the only 2 steps I could do is a full recovery, restore from Sunday's backup, and a restore from Wednesday's backup. I wouldn't be able to do anything to recover my transactions from Thursday. That's the reason we don't want you to use simple recovery model. So it kind of explains that piece, but how do I avoid the ginormous transaction logs? That's the bigger problem, and I'd say, again, 25% of the people I present to raise their hands when I say, how many people have seen the ginormous Tlogs with just a baby transaction log or a baby MDF file? And I get 25% most of the time that says, yep, been there, done that. Well, how do I avoid that? What we're going to do is, at what point in this entire process of backups do we not care as much about what's in the LDF file? So if we think about it, if we're doing differentials, we still are concerned about what's in the transaction log file. But really on Sunday, when I do that full backup, after I've completed a successful full backup, I'm really not as concerned about what's in my LDF file. So you may read online, the documentation may say, when you do a backup, a full backup, it backs up your transaction log. It does kind of sort of, but it doesn't back up, it doesn't truncate it. So what we need to do on Sunday, right after we've had a successful full backup, is we're going to perform one more command. So we just write a job as a DBA. It says on success of step 1, which is the backup, to do a full backup, On success of that, we're going to now back up that log. When I issue a backup log statement, that truncates out that ginormous, or that content that's in there. We're not going to allow it to get ginormous because we're going to do this every week. So every Sunday, after a successful full backup, I'm going to issue the backup log DB name to any directory. I don't care where it goes, and I can use the with init command. And what that will do is next Sunday, it's going to back up the same log, and it's going to purge it out, and it's going to leave it out there for the full week in the event that you want to use that. Quite frankly, you could actually come out here and do a third step here. So do a full successful backup, do a backup log of the transaction log, and actually turn right around and delete that weekly_t_log.bak. I don't really need it. All I'm doing, the only reason I'm doing this text in blue, this backup log statement in blue, is so my transaction log doesn't get huge on me. So what I want to do to avoid ginormous transaction logs is not put stuff in simple recovery model. That takes away the opportunity for me to recover transactions from Thursday in this scenario. So how do I avoid the ginormous transaction logs? I put all this in place here, and specifically the text in blue. After a full recovery or backup, let's say on Sunday, at that point is when I do a backup of the transaction log that purges it out, shrinks it down, and avoids it becoming too large. You're building a castle over there. So that's our point on this, on how we want to avoid ginormous T-logs by still allowing you to be able to do any recovery because you still have content in your transaction log. All right. SQL Server backups. We just talked about the idea we need to do backups, all right? Now, coming out of SharePoint, we have full backups, we have differential backups. DBAs can do full, differential, and they can do transaction log backups. So in this piece, we're going to talk about backups and the importance of those backups. There's 3 P's when it comes to backup. You got to plan for them, you got to perform the backup, and you got to practice the restore, all right? Practice is probably the most critical. Well, I'll say the second one. Perform is probably the most critical because there's nothing to practice if you haven't performed the backup. But if you haven't practiced the restore, you're going to probably run into issues when you try to do that restore thinking there is content in this backup directory or this backup tape and there's nothing there. So I want you to plan, perform the backups, and practice the restores. And do that regularly to make sure that you understand a crisis. What you don't want to do is have a SQL Server database go down and you're trying to figure out how to restore, or the CEO or CIO calls up and, hey, I understand SharePoint's down, we lost our database, how long is it going to be? Well, you're sitting there proud as a peacock saying, actually, this hasn't happened since I've been here as a DBA for 4 years. I don't know how long it's going to be. That was probably, I would call that an RPE, a resume producing event, because what you've just told your CIO is like, I don't know, I've not practiced this, I'm not really quite prepared for losing a database. You were bragging that you've never had to, that's good, you've got good hardware, but you've just also, RPE'd yourself because now you've said, I haven't practiced this, I'm not sure how long this is going to take. So plan, perform, and practice that restore to avoid those RPEs.
Yeah, I think there's a number of reasons why you would want to do that. Obviously, reason number 1 is you definitely want to determine duration of both backup and restore, because those are going to map directly to your RPO, your RTO objectives, and impact your overall SLA. Beyond that, you also want to ensure that your backups actually completed successfully and they're capable of being restored. I've seen a number of cases myself where there's 90 days of backups, but within that 90-day window, perhaps 15% of them failed. Yeah. Generally, what happens is 100% of restore requests are related to the 15% of the backups that have failed. So you definitely want to think about that. You also want to kind of plan backups around SQL Server version as well. Think about stuff like backup compression. So you really want to look at the version of SQL Server that you're using so you can implement some of those capabilities, such as backup compression. Beyond even that, SQL Server versions are also important as you think about stuff like content deployment, right? You want to be able to leverage snapshots for content deployment. Equally applicable, evaluation site collections in SharePoint 2013. If you're running Enterprise Edition or Developer Edition of SQL Server, it's going to leverage the snapshot capabilities of SQL in order to implement evaluation site collections, which means there is no outage and those evaluation site collections become more instantaneous. If you're not using a version supportive of database snapshots, what you're going to end up with is kind of the traditional backup and restore routine that we'll leverage through our API. So SP site backup, SP site restore. What that means at the end of the day is that's a read-only outage for the duration of the event. If we come all the way back to large site collections, 100 gigabyte site collections, somebody wants to create an evaluation site collection, you're on standard edition of SQL Server, it's an SP site backup, SP site restore. So you can imagine there's a significant duration of time in which it's a read-only outage, as opposed to if you were using a version of SQL Server that supported snapshotting. And then lastly, there's other capabilities as well, such as transparent data encryption and a number of different things. But as I mentioned, in respect to SQL Server 2012, specifically, largely around the area of file table, we're going to have some guidance in terms of what capabilities you can and cannot leverage in the form of a white paper here within the near future, now that we've kind of made it through our release milestones. So I'm going to go ahead and turn it back over to Frank, let him talk a little more. One of the other things I wanted to bring up, psych, is that
Frank, it's like, wow, Frank's here too.
Yeah, I know. I've got Frank on my mind.
Frank in front of you.
Yeah. So one of the other things I wanted to bring up now that Brian's kind of concluded some of the backup stuff is how do you really plan for backups? And my general recommendation is, and I think Brian's going to talk about it, is what do you keep on disk versus what do you keep on tape, and how do you distribute those backups? So I'm going to go ahead and turn it back over, let him talk about that, and then I'll chime in again as I fire up some Angry Birds.
All right, backups, location, location, location. You've heard that for real estate. It's also very applicable to your backups. So what we need to do is when we talk about backups is we need to have a local copy for a quick restore operation or a quick disaster recovery. But we also need to think about a remote copy. And when I talk about local and I talk about remote, it really depends on where we're at, maybe even geographically where we're at as to what is considered local, what is considered remote. So a local copy for quick recovery. Do you want your backups in the same room as your production server? Well, what if a sprinkler head goes off? Usually if one sprinkler head goes off, they all go off in the same room. So that's probably not a good idea. What about in the same floor? At least they're out of separate rooms. I think some sprinkler heads may all go off on the floor at one time. So you have to be careful about that, the location of that backup server. Same building. Again, it's back to where we are. Same building may be okay. California, they're known for what? Those things called earthquakes. Will the backup server in that building be, the best possible scenario for me? You get into same city, get in the Midwest, where Tornado Valley down there. Having a backup even 2 blocks down may not be acceptable. So things we need to take into consideration when we talk about the location of our backups are just a local copy. First off is how quickly can I recover? We want to minimize the downtime, granted, but we also have to think about the placement of our server that's going to host, or our tapes that's going to host that recovery, that data for that quick recovery. So think about that. Take that into consideration when you're trying to figure out where to store your local quick recovery backups. Now, for larger disasters, or for large disasters where things like you go into, again, we'll go back to Tornado Valley. Do we want to put them in the same county? Now we're talking our secondary. So we're always going to have a local copy, but now we want to have a remote copy. Well, I might have a local copy in the same building, say, we're not in Tornado Valley, but I'm going to have a remote copy, a city over or a county over. Well, we have to think about all that. We have to think about natural disasters and the time it's going to take to get to that third or that remote copy. So you have your production, you have your local copy for quick recovery, and then you have your remote copies. So remote copies for larger disasters, same county, maybe. For Tornado Valley, maybe not. Same state, Tornado Valley, maybe not. Same geographical location. That covers several states. Maybe we send all our backups on tape every 90 days or every 30 days to Arizona or something. We have no natural disasters out there. We get snow every once in a while and it shuts down the city. First time in 12 years. But there's really nothing to be concerned with out there. So there's a lot of big data centers out in Arizona because there's really not much to be concerned with except for heat out there. Well, and rattlesnakes and scorpions, but they usually aren't in your data center. So when you're looking at backups, the location of them for quick recovery, think about the placement of that. Think about also another copy of that, and where you should store that remote copy. The same city may not be far enough for that remote copy. And I don't know how many people have probably gigs of MP3s. How many people actually back up their MP3s or have them on one server or on your desktop? and you don't back them up to your remote drive. Probably spent hundreds and hundreds of dollars compared to millions of dollars for an organization, but you'd be quite upset if that drive crashed on your computer and you lost those gigs and gigs of data. So again, what do? You buy an external drive and you back up the content to your external drive. Where do you store the external drive? Not in your house, I hope. Maybe your grandmother's, your mom's down the road. So when you bring it back down to a personal level, backups, whether we're talking about MP3s or videos or data for a company, we always have to think about making sure we're performing a backup. And secondary to that, or as important as that, is where we're going to put those backups after we perform those backups. We need a local copy, and we should have a remote copy for businesses.
And I think one of the things that I generally recommend to people is as Brian mentioned, you want to have a very localized copy, low latency that you can achieve or retain or bring back quickly. And then the other one, obviously, is you want to have another copy of that data that's stored offsite. So, what I've seen with most organizations is kind of the 21-day regimen. So that's 21 days on disk. The way that they distribute it is they perform 3 full backups within that 21-day window and 18 differentials. So that gives them 21 days, and it also helps mitigate the size, because that's another thing you need to plan for. You need to think about the size of your backups. If you have a 1 terabyte content database, for example, and you want to do 21 days on disk, that means you're going to have 3 full, so that's 3 times that plus any differentials. So you have to think about kind of what your change or churn rate is on that database. So theoretically, you could use 5 times as much storage for backups as you would for the actual content you're protecting. Following the 21-day regimen, you can move to disk for, say, 90 days. Or every 90 days you can take a copy or to tape and move it off the tape and then offsite that copy of your data. So you always have fast access for the previous 3 weeks, or you have historical access offsite that takes a little longer to get to, but generally most restores are within that 3-week window. From a performance perspective, you are going to be using significantly more disk for backups than you would be for the actual production content itself, or the content that the backups represent. I generally recommend using slower disks. Use large SATA 2 disks. You can buy large 1 terabyte disks. RAID 5 is sufficient enough for backup, so you generally don't want to use something like RAID 10, because then you're cutting your storage in half, or effectively another way to think about it is I'm doubling the cost of my storage for the purposes of backup. So you really want to think about how you optimize those drives, which is generally not optimizing from a performance perspective. For example, you don't want to throw a bunch of SSDs back there for backups. 1, because size-wise they're typically smaller, and 2, they're much more expensive, and then depending on how you format those or what array type you choose, it can significantly increase costs. So my recommendation is typically RAID 10 for just about everything SharePoint related, and then RAID 5 for everything backup related, faster disks for production data, and slower, larger disks for backup data. So I'll turn it back over to Brian.
Excellent advice. SQL Server always on. Talk about high availability or redundancy and the ability to recover quickly. We're going to go into a section here that's new to SQL Server 2012, and it's called Always On. And we're going to talk through some of the components of this and talk to its behavior. But it's something you should certainly be looking at for SQL Server 2012, which will allow you to recover your SharePoint content much quicker and shorten that latency. So just an overview of SQL Server 2012 Always On. It requires your Windows Server failover clustering. So that's a component, that's the core component. It builds on the SQL Server mirroring. So the mirroring that we're used to is, it's not going away, it's being enhanced. It's part of this always on. So you might see some, hey, we got rid of mirroring. Well, it's not true. It's been rolled into the clustering, and those two have been kind of integrated together to provide this always on capability. Now, regardless of, just like any version of SQL, any version of any backup a situation or scenario, it's always on is not a replacement for your database backups. You still need to perform your regular backups, as we talked about earlier on this module. This is not going to say, okay, I've got always on, which includes clustering, which includes mirroring. I don't need to do backups. It's not true, as in any case, and we've always taught that, and stress that throughout every version of SQL Server, every version of SharePoint. You still continue on with your database backups. There's some components. I'm going to ask Bill if he'll talk to this. Components that we have availability groups and databases and replicas and modes and failover types. So there's some components, some terminology and concepts that you'll have to become familiar with. But when you get your head wrapped around that, you're going to see that the always on is going to provide you really a significant amount of improvement, I think, of providing a high availability, as well as backups are a way to recover content fairly quickly.
Yeah, and the way that I like to look at always on is it's kind of the evolution of high availability and disaster recovery, and it encompasses both, and it's fairly representative of the first SQL Server solution that can actually cover both high availability and disaster recovery. If you think about database mirroring, by itself in SQL Server 2008 and even earlier after SP1 with 2005, that was more of a high availability solution than anything else. You had a production copy of your data and an inaccessible warm standby copy of your data. You had log shipping, which kind of facilitated the disaster recovery aspect, complementary to database mirroring. So what you ended up with is you had a solution, you had two solutions. You had high availability covered by either database mirroring or failover clustering, right. And then you had log shipping, which kind of represented the disaster recovery aspect. And the reason people implemented both is mirroring was a one-to-one relationship. You had one copy of your production data and one warm standby copy of that data. Log shipping enabled you to have multiple copies of data representing one source. So you had one source with multiple copies. Always on takes both of those technologies and really delivers both. So it's based upon mirroring, which is what Brian brought up. So mirroring is deprecated in favor of always on, which provides the foundation for always on. But mirroring now looks a lot like log shipping. You can have a single copy of the data replicated to multiple locations, and that's where the always on availability group replicas come from. So I could theoretically replicate my content databases from, say, one point in the world to another point in the world, have them be read-only there, and then I can replicate them subsequently to another point in the world and have them be inaccessible there, so no read activity whatsoever, so effectively they're locked. And I can use them in different ways. The other benefit of always on as well is those readable copies. So if I create a availability group with a replica and that replica is readable, I can perform backups against it, and that's something you couldn't do with database mirroring in 2008. So now I no longer have idle hardware, and that's one of the things most people didn't necessarily like about database mirroring by itself, is because they saw the secondary set of data as idle hardware. It was data that sat there, but you couldn't access it or do anything compelling with it. Now you can actually back up from it. So there's an opportunity to leverage always on for some of that. That's kind of the availability group aspect. All of this is built on top of Windows Server failover clustering. That becomes a requirement for availability groups. So even though you're not clustering SQL Server, Windows Server has to be clustered. And the reason it has to be clustered is that's where we get the uniqueness of the name that we can transition across our availability groups in the event, or our replicas in the event that we need to fail over. So fundamentally, you create a Windows Server failover cluster, you install 2 default instances of SQL Server on separate machines, and then you create your availability group across those machines. And you can do that a number of times per availability group. We have failover cluster instances, which are new. They provide some capabilities such as multi-site or multi-subnet failover, so that's an improvement from an always-on perspective. And that, that kind of summarizes what you get from an always-on perspective, at least in terms of what Brian just asked me, related to the components that you have available to you.
Yeah, and so as you can see here now, we've got, as Bill pointed out when he was discussing it, we've got database protection and instant level protection. So we've got multiple database failover, we've got multiple secondaries, as he talked about, active secondaries, so they're not just kind of wasted hardware and that's kind of just hanging around. And then at the instance level, we've got the flexible failover policy, multi-site clustering. So it provides availability for both on-premise as well as the public cloud and for private. So definitely it's just definitely I like the combination of the mirroring, the log shipping, providing both a high availability as well as the protection, the redundancy that we have. So what are the requirements? We talked about the components. The requirements are all the cluster nodes running Windows must be running Windows 2008, Server 2008 or R2. They have to be in the same Active Directory domain. The failover cluster user creating a cluster has to have certain permissions. Kind of sounds like setting up the user profile application now. You have to have an Active Directory domain account. You have to have create computer objects and read all properties, read all properties rights in Active Directory. Administrator permissions in cluster and the cluster nodes that you're working with within that when you're setting up the Windows clustering. If you're interested in this, which I'm sure you are, there's an article here about that references or discusses the always-on requirements to make sure that you've got everything in place to take advantage of what I think is a really neat additional functionality that they've added in SQL Server. And there's also a couple recommended hot fixes you might be I want to just double check to make sure that they're not required by you, but if they are required by you, that you can add these hot fixes, and those are listed here as well. All right, the other thing we want to do is verify the integrity of databases. What's this DBCC command we've been talking about?
Yeah, I mean, from a DBCC perspective, I'm still old school, I guess, in respect to database consistency checks. Even though I showed you some DMVs earlier, so I'm starting to slowly adapt to DMVs. I still like DBCC. As I showed you with the show config command, it is much cleaner in terms of the way it presents the result set versus the DMV. And then obviously for those people that aren't as familiar with SQL Server, you have a number of different opportunities you can use to actually perform, consistency checks. And one of them is to right-click the index that you want to look at. In the case of the all webs table, I looked at the webs primary key column. I looked at the clustered index, right-clicked, properties, fragmentation. You can rebuild and reorganize from there as well. From a consistency check perspective, with SharePoint, we don't support allow data loss, obviously, because what it attempts to do is you perform a database consistency check, and you specify the allow data loss parameter, which will repair any errors inclusive of committing any data loss. Obviously, with SharePoint, we talked about a little bit earlier about why you don't want to modify our schema or change anything from a schema perspective, because we do have enforced integrity, we do have constraints, and there are reasons why we try to keep our schema as untouched as possible. Obviously, the application of service packs, cumulative updates, public updates, they all have a dependency on schema. So repair, allow data loss, it's not an acceptable argument that you can use. With DBCC CheckDB, you can use repair rebuild. Basically, it'll only perform repairs that have no potential of data loss. To give you an idea, we can just switch over to my machine again. I can come in here, go to my content database. I'm going to do a new query, DBCC CheckDB. I'll just run it generically, execute. What it's going to do is it's going to execute the query, and it's going to give me a result set. If I go all the way down to my all webs table, it'll show me the number of pages currently allocated or used. If you remember, a page is 8K, and extent is 8 consecutive pages representing 64K. So, 8 times 4 is what, 32. If I go down to my all webs table, it's likely 33. So obviously, as a result, if we look at the number of rows comparative to the number of pages, we can see that there was a page split from an all webs perspective as we work our way through the result set. So I can do a repair rebuild. Again, I won't do it here just because of the time it takes, because it will only repair issues that will not result in data loss. Otherwise, you cannot use the repair allow data loss argument with DBCC CheckDB. We don't support that with SharePoint. As I go through here, you get your result set, and then you can use your result set to determine whether or not any issues exist, and you can begin your maintenance operations from there. From a DBCC perspective, I generally recommend frequently running it. You want to know, or you want to be proactive as possible in terms of checking the consistency and integrity of your databases. You want to know when a problem exists as soon as that problem actually occurs in the environment. You don't want to find out about a problem that existed in January sometime in June. You want to find out that January problem, you either want to figure that out in January or figure that out in February. You don't want to let a large portion of time passing between an actual error occurring and when you discover that issue. So consistency checks are something that I recommend doing at a frequent interval, just to maintain the health of your databases. If you have a lot of databases, you don't necessarily have to perform it against each one. It's much like testing backups. You don't want to restore every single backup to verify that your backup's completed successfully. You kind of want to just select a subset, typically say 10% If you have 10 content databases, take one of them and restore it. Determine the success of that. Perhaps during your next backup routine, you select a different one of those 10 and perform a restore against that. That'll help protect yourself that way. DBCC you can do the same thing with. So you can perform consistency checks against a subset of your databases at varying intervals just to ensure that everything's running smoothly.
All right, so DBCC check DB, easier said than done, or done than said, I hope. But this, as you pointed out, that's why we didn't want to kick it off. It is a time-consuming operation, so you don't want to run this during peak hours. Do take take this off hours and run that to determine how your databases are standing. All right, we're going to wrap up with some of SQL Server for SharePoint best practices over a few slides. Kind of a little bit of a review what we've talked about in these 4 modules today. So we're going to go through and kind of refresh your memory of what we talked about, and then we'll be just concluding this course. First off, probably one of the things we've been emphasizing since Module 1, get a dedicated instance at the least of SQL Server for SharePoint. You saw several reasons as we went through the slides today and the demos today why that's important. Changing the collation, changing the instance settings, changing the of memory, changing the file locations. Very, very important for you to have that dedicated instance of SQL Server. Again, it can run on the same server that's hosted, physical server as hosting another machine, but you want a dedicated instance of SQL Server for each instance or each SharePoint farm. Modify the tempDB and model system database settings. We walked you through those settings. The initial size is key. The auto growth setting is key. Remember, by default, what happens if you create a database from inside of SharePoint, the auto growth from the model database is not applied to that database. So you have to make sure that you talk to your DBAs over one of your monthly lunches to remind him of that situation.
Yeah, I think one of the things you need to think about is auto growth is, as stated in the slide, and I guess everybody can read as well as I can. It's an insurance policy. So you definitely don't want to use auto growth as kind of your catastrophic recovery option. You want to use it sparingly. Use it as an insurance policy, but typically the recommendation from a performance perspective is to just size your databases appropriately. So if you know in your environment you want 200 gigabyte content databases or 500 gigabyte content databases, size those content databases up front and then use auto growth as the insurance policy. Don't start with a 10 gig database and allow it to auto grow up to the 500 gigs that you ultimately would want at the end of the day. So it's really about being proactive with sizing as well as being proactive with maintenance. So generally that's just the approach that you want to take. From a shrinking perspective, got a number of questions regarding when should I ever shrink? Never. Particularly with SharePoint. And why do I say never? So from a SharePoint perspective, shrinking is all about white space reclamation. You're going to get a little bit of space back, but because of the nature of SharePoint, you're going to consume that space again. All you're going to do is pay a performance penalty and increase fragmentation as a result of trying to shrink. You're really not going to gain anything back in terms of shrinking from a size perspective. All you're going to do is pay the performance penalty, increase fragmentation, pay another performance penalty because of that, and then auto growth is going to kick back in. So like I said, all you're going to do is kind of exacerbate a bunch of other problems if you're looking at shrinking as one of your options. Before Brian kicks in on the next session, questions, we're working on getting those answered, but if none of your questions have been answered by the time we conclude today, if you refer way back to the first module, both my and Brian's Twitter handles were there, so you can also ask your questions that way following the session, and we'll be sure to get back to you.
All right, we'll continue on with some best practices. I know we are getting close to our downtime here, so we're going to spread our data files and transaction logs across multiple physical drives. We talked about that when we were discussing the idea of transaction logs on separate drives than their data files. You'll see how that will you saw how that would benefit you in the event you lose the MDF file. You've got your transaction log file to recover from, because we are going to be wise DBAs and not put anything in simple recovery model regarding production content databases. We'll put those in to leave them in full recovery. Now, if you're in development and you're not worried about the content and you want to put them in simple recovery models, you don't have to worry about it. Different story, but we're talking production here as we're going through these best practices here. Create the SQL Server alias. Bill went through the difference between the SQL Server alias versus the DNS alias.
Right. So a little bit earlier we mentioned A little bit earlier, we mentioned SQL Server aliases or client connection aliases versus canonical name records in DNS. And as we talked about in the very, I believe it was the first or the beginning of the second module, one of the things that we talked about is when do you choose one over the other? And obviously, a canonical name or a DNS record or an alias in DNS is the preferred methodology from a resiliency perspective, mobility perspective. It provides the best opportunity. And again, if you don't have the relationship with your identity team, you don't have operating level agreements in place, or you really own SharePoint's infrastructure end-to-end beyond just Windows and SQL Server, then a client connection alias could be right for you because obviously you can get that done a lot quicker because you have more access to the infrastructure around SharePoint. But if you do have the identity relationship, the infrastructure relationship, and the proper OLAs in place, the path forward is really to use canonical name records as referenced on TechNet. Content databases, albeit after Service Pack 1 with SharePoint 2010, we did improve those limits. So as many of you remember, 2007, 100 gigabytes per content database, early 2010, 200 gigabytes per content database, post SP1 for 2010, up to 16 terabytes in kind of an incremental state. 200 gigabytes for general collaboration workloads. Also, it's our recommendation. One, from a backup and recovery perspective, and two, it works across a variety of different infrastructures, whether you're using direct attached storage, some kind of content addressable or commodity storage, or even high-end SANs. 200 gigabytes represents the best opportunity. It can be backed up rapidly, restored rapidly. If you have large site repositories, records management, read-only workloads that do not represent, say, a collaborative I/O profile, then you can obviously think about 4 terabyte, 16 terabyte, and scale up that way. But scaling out is the typical recommendation as related to content databases because it provides the best opportunity from a performance perspective as well as just general operational perspectives. Shrinking. We just talked about shrinking, which is the third bullet in this slide. Avoid shrinking database files. We talked a little bit about that. Frequent database integrity checks or database consistency checks using DBCC CheckDB or another preferred mechanism. You want to monitor latency, so you want to be very you want to take a very proactive approach in terms of latency to ensure that from a latency perspective you're well within the boundaries that we recommend as related to SharePoint. Index fragmentation we talked about, so I showed you a couple of different ways that you can measure fragmentation, whether it's by virtue of show config with DBCC or by virtue of using DMVs, also by using the SQL Server Management Studio. So you can measure fragmentation in a number of different ways. I just made that plural. So you can measure it. You can measure it in a number of different ways to figure out where fragmentation exists, and then you can resolve it in a number of ways. Transact SQL or via the UI. Sometimes reorganize isn't sufficient, and you need to revert to a rebuild. But don't only think about indexes, and that's kind of one of the things that people think about is I'll just continue to monitor fragmentation at the index level. What about the drives that the actual databases reside on? You need to think about those. And then backing up, and Brian's already talked extensively about backup and restore, so obviously he's had some past challenges with being able to restore content.
Yeah, it's definitely you want to be able to, again, avoid the big thing here, avoid the RPEs as we go through as well. A lot of what we talked about today, by taking these best practices and taking what we discussed, should help you optimize your SQL Server / SharePoint environment, should help you avoid the RPEs, and hopefully everything that we've discussed today you'll find helpful and beneficial. I know this will be available off the MVA, so we are going to wrap up here with just a summary of this module. Avoid the ginormous Tlogs by performing regular transaction log backups. All right, avoid that simple recovery model. That's not the solution. Create multiple copies of your backups. Location on that. Okay, take advantage of the AlwaysOn, which is a combination of the mirroring and the log shipping. Gives you both high availability and data recovery. Verify the integrity using our DBCC CheckDB, and just follow those best practices that we've shared. So we want to thank Frank Gartland. We also want to thank.
We don't want to thank Frank yet.
You don't want to thank Frank?
No, we don't want to. We don't want to thank Frank quite yet because we still have a little bit of time.
Oh, okay.
And everything could go wrong between now and then.
Oh, that's true too. Yeah, he's been in the background. He's been quiet, so we got to thank him for that. But Marguerite and Nakanda Brueggemann, who work for Lewis and Clark, they jumped in today and handled some of the questions behind the scenes. So check them out. LewisandClark.edu, I believe, was their website. So thanks very much for your help.
One of the other questions that keeps coming up, at least in the Q&A, that I'll just kind of address for everybody's benefit is there's probably still some confusion around sizing and remote blob storage when those two are placed in unison. Basically, the way our sizing guidance works is our recommendations in terms of sizing, whether it's 200 gigabytes or anything other than 200 gigabytes, is it's always the sum of your structured and unstructured data. So what does that mean? Regardless of where your unstructured data lives, your unstructured data is represented by your binary large objects, your blobs. Think PowerPoint presentations, any kind of files you upload to SharePoint. Your structured data is representative of the corresponding metadata for that particular blob. So the sum of structured and unstructured data, regardless of where the unstructured data resides. So if you're using RBS and you put your structured data or your unstructured data in the cloud on some commodity storage device, it still factors into the 200 gigabyte, 4 terabyte, 16 terabyte limit. So using RBS doesn't enable you to bypass any of our boundaries in terms of capacity. We always include the blobs regardless of where the blobs exist. The reason we do is from a performance perspective, even if you're using RBS, there are times to which we still touch those blobs. So from a maintenance perspective, a cumulative update. So if you think about promo and demo, we still touch blobs in that respect. Some of the upgraders actually touch the blobs in order to perform some of those activities regardless of where those blobs are. So it's inclusive of both. So you need to think about it that way. From a sizing perspective, again, pre-size your databases and get them there. Instant initialize is something that can definitely be useful from a SharePoint perspective as you think about the way that you want to manage your databases. The other thing I wanted to do too is for all the people that have answered questions, Brian hasn't answered a single one yet on the Q&A. So unfortunately, I've been relegated to doing all that work. I just wanted to call him out.
Nicely done. I was driving the slides.
That's hard work.
Yes, I know. Okay.
So at any rate, as he did the heavy lifting of pressing next on the keyboard, like I said, there's still a number of questions that we'll try to answer within the next couple of minutes that we have out here on the Q&A. Otherwise, again, you can reach either of us on Twitter or a number of different ways, and we'll answer your questions that way.
Sounds good. Thanks again for taking time out of your busy schedules to join us here on this tuning SQL Server for SharePoint Jumpstart. Again, check out your MVA. Make sure you take down that code for your points and make sure you register that and get that submitted by the end of the month. And Bill, thank you very much. It's a pleasure working with you, sir, definitely. And I'm sure we'll be doing something somewhere like this soon.
Thanks for coming to visit the sunshine in Redmond.
It's my pleasure. Take care.